In this video, I'm going to walk through the solution for number 6 on the Unit 8 review packet. The question asks us to find the volume of the solid created when the region between f and g is revolved around each line. We're going to set up but not solve these integrals. The two functions we're looking at here are f of x equals x plus 4 and g of x equals x plus 7. And we're looking at the interval from 2 to 5. There are 4 parts to the question. Part A asks us to find this around the x-axis. Part B says to revolve around y equals 2, C around y equals negative 2, and D around y equals 15. In order to do this, we are first going to draw a sketch. So I'm going to jump to the solutions here. And you can see I've drawn a sketch. The x-axis is right here, where you can see A labeled. The y-axis is right here with little tick marks that represent intervals of 1. I've graphed f of x, which has a y-intercept of 4 and a slope of 1. G of x, which has a y-intercept of 7 and also has a slope of 1. I've also shaded the region between x equals 2 and x equals 5 so that we can see that that is the region that we are revolving around each of the various lines. The other thing you may notice is that all of our lines, whether it's the x-axis, y equals 2, y equals negative 2, or y equals 15, are horizontal lines, and that there are gaps between our region and the axis that we're revolving around, which is why each of these involves the washer method. So the washer method is based on the geometric formula pi r squared times height. However, because of the gap, we have to take the outer radius squared minus the inner radius squared. The formula for that can be found on the back of your curriculum map, among other places. So if I jump to that, you can see it right here. Pi r squared times height, where we have to take the outer radius squared minus the inner radius squared. All of these regions are from x equals 2 to x equals 5, so we don't have to worry about messing around with the lower and upper limits of integration. But the big thing is we have to decide what our outer and inner radius are. So if we were doing part A, we are taking this region and we're revolving it around the x-axis. So it's pretty easy to see that g of x is our outer function because it is farther away from the x-axis than f of x. So if we were going to set up the integral, it would be as simple as pi times the integral from 2 to 5 of g of x squared minus f of x squared dx. And you can see that right here. Since we are setting up only, that is our answer. I did fill in g of x, x plus 7, and f of x to be x plus 4. Definitely the easiest of our 4 that we're going to look at here. Now, part B says let's revolve that region around y equals 2. If we're going to revolve that region around y equals 2, then we have to change a little bit. Our outer radius is still going to be g of x. G of x is further away from y equals 2 than f of x is. However, we're not going all the way back to the x-axis. We're going from g to y equals 2. So the distance from g all the way to the x-axis is, of course, just g. But we don't want to go all the way back to the x-axis. We only want to go back to y equals 2. So I'm going to draw this first line here is from g to y equals 2. But I can't just call that g of x because g of x is actually the distance all the way back to the x-axis. So if I only want this distance here, it's going to be g of x minus 2. Similarly, my inner function f, since we're revolving it around y equals 2, doesn't go all the way back to the x-axis. It only goes to y equals 2. So the distance from f all the way to the x-axis is, of course, f, which means the distance from f back to y equals 2 is going to be f minus that gap of 2. So my outer radius is not just g of x, it's g of x minus 2, and my inner radius is not just f, it's f of x minus 2. So the integral is relatively easy to set up once you realize that. It's going to be pi times the integral from 2 to 5 of g of x minus 2 all squared minus f of x minus 2 all squared. And the setup can be written just like this. So you can see pi times the integral from 2 to 5 of g of x minus 2 all squared minus f of x minus 2 all squared. Outer radius squared minus inner radius squared. Part C asks us to revolve around y equals negative 2. So in a similar fashion, we have to decide what's our outer radius, what's our inner radius. And we're going to do the same thing here. We're going to draw in some radii to decide what they are. So if I'm going to revolve this region around y equals negative 2, then my outer radius is still my g function, but I'm going all the way past the x-axis. So from g to the x-axis is g of x plus an additional 2. So that my outer radius is not just g, it is g plus 2. My inner radius, similarly, goes from f to the x-axis and then an additional 2. So my inner radius is not just f, it is f plus that additional 2. So this is again a washer because of the gap from our region and the axis we're revolving around. So we take the outer radius squared minus the inner radius squared. The integral would be pi times the integral from 2 to 5 of g of x plus 2 all squared minus f of x plus 2 all squared dx. You can see the answer here. Pi times the integral from 2 to 5 of g of x plus 2 squared minus f of x plus 2 squared dx. Part D changes things up a bit and asks us to revolve around y equals 15. Y equals 15 is now above our region, which means our outer and inner radius switch. So if I'm looking at this region here and I want to revolve it up around D, y equals 15, now my f function is farther away than my g function. So my f function becomes the outer radius. However, my f function, if I'm measuring it, always goes back to the x-axis. So if f comes back to the x-axis, that means this right here is f but I want this to be my outer radius. So what is that length? Well, from all the way here down is 15, and this is f, then that means my outer radius is 15 minus f. Similarly, my inner radius this time is going to involve the g function, but my g function comes back to the x-axis. So if this is g, and all the way down again is 15, then my inner radius this time is 15 minus the g function. So, to set up my integral, it'll be pi times the integral from 2 to 5 of my outer function, 15 minus f of x all squared, minus my inner function, 15 minus g of x all squared, dx. And you can see that here on the answer key. Pi times the integral from 2 to 5 of 15 minus my outer function squared, f of x, minus 15 minus my inner function squared, and of course that's g of x.